Again, working with stoichiometry. Stoichiometry takes a look at the amount of reactants and products involved in a reaction. It allows us to go from one side to the other to predict how much material we're going to need, how much we might have left over, how much is going to react, how much of A will react with B. And so that's kind of the really cool part about stoichiometry. So we'll start right off with an example. Question. So another reason, you're not going to know what we're doing if you don't write it down. Another reason I like stoichiometry so much is that it's real. It's real life problems, real life situations. Now, do you guys actually ever care about any of them? No, probably not. But it can be. It can be very real. You can use it to solve real world problems like this one here. A lot of you guys probably have a propane grill at home out back. You might not even know you have it, but if you have a gas burning grill, chances are it's burning propane. Now, you may not use it, and this time of year, I doubt anyone really uses it. It's way too cold to go outside for any extended period of time. But in the summertime, you fire that thing up and you grill out, and that's propane you're burning. So, the question stoichiometry can use to solve is, let's say you have 0.65 grams of gas, propane gas. How much oxygen will you need to burn that gas? Well, number one, always. Always start with a balanced chemical equation. Sometimes your homework is going to tell you step one, balanced chemical equation, or show a balanced chemical equation. Other times it doesn't. It just asks the question. Either way, you're going to need to start with a balanced chemical equation. You cannot do stoichiometry without a balanced chemical equation. You have to have a balanced chemical equation. So let's get one for our reaction. We have propane, that's a hydrocarbon. It's going to react with oxygen in a combustion reaction. So hopefully reading the sentence, we can figure out what type of reaction we're going to need. We need to figure out the chemical formula for propane. Some of you guys might be able to remember what it is or kind of visualize it. Awesome, good for you. Me personally, I got to write it out. So prop means 3. So there's our 3 carbons. The A and E tells us all single bonds. So we need to fill up the rest of these carbons, the rest of these with bonds. Make sure each carbon has 4 bonds. On the end of each of those empty bonds, then, I'm going to put a hydrogen. Oh, there we go. There's propane. Again, I know some of you guys might have shortcut ways to do that. Fantastic. Good for you. That for me is the easiest way. Yeah, it takes up a little bit of room, takes up a little bit of time. But now I know the chemical formula for propane. C3H8. 3 carbons. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. There's my propane. It told me it's a gas. Might as well add that little detail right away. And then the rest of it is pretty easy. We always have a hydrocarbon reacting with oxygen, and it always forms carbon dioxide and water vapor. So there we go. There's our material from last chapter right there. We can predict products. Mohammed, stay with us. Stay awake. So there's our chemical reaction. Now we need to balance it. That takes a little bit more thought process. 3 carbons, just 1 carbon. I can fix that pretty easily. 3 carbons, 3 carbons. 8 hydrogens, just 2 hydrogens. Again, I can fix that pretty easily. 4 times 2 is 8. Now I've got 8 hydrogens and 8 hydrogens. On the left, I've only got 2 oxygen. That'll be easy to fix, though, as long as I have an even number. Let's see what we got. 3 times 2 is 6. 4 more is 10. Yes, we can do that. 10 oxygens. 3 times 2 is 6. 4 more is 10 oxygens. Cool. There's our balanced chemical equation. Here's the beautiful part about a balanced chemical equation. Thank you. A balanced chemical equation gives you mole ratios. So that's the whole reason why we did that last chapter. So we can see how many moles of each compound react with moles of the other compound. For the ones we're looking for oxygen and propane. So that mole ratio, it's an implied 1 if there's not a number there. That mole ratio is 1 mole of propane is equal to 5 moles of oxygen. In other words, it takes a lot more propane. It takes a lot more oxygen than propane. It takes 5 times as much oxygen as propane to react. Now, we did a little bit of this first semester. I don't know if you guys remember or not. It's been a while since it's like September. But we did a little bit of this first semester. There's 2 ways I can write this. Mathematically, I don't just want to write it like this. Mathematically, I can set this up either 1 mole of propane per, that line is like per, 1 mole of propane per 5 moles of oxygen. That's one way we can mathematically set it up. Or five moles of oxygen per 1 mole of propane. And guys, this is the same exact thing. Same exact thing. It's like saying 4 quarters is $1. Or $1 is 4 quarters. It's the same thing. I can go to McDonald's and buy 2 cheeseburgers for $1.39, or for $1.39, I can get 2 cheeseburgers. It's the same thing either way. What's important is that when we set up our work, which we'll do here shortly, we have to make sure that we get the units in the right place. If we're trying to divide out moles C3H8, then we want to use this one. We want that on the bottom. If we're trying to divide out moles of oxygen, we want this on the bottom. So it all depends when we set up our units, which one we want on bottom. All right, so that's first step. Balance your chemical equation. That gives you mole ratios. Second step, get your chemist's best friend out. Oh yeah, we're going to use this again. The old periodic table. The old periodic table. You will use this a lot, so go ahead and get that out. Give you guys a minute here. We're going to need that to calculate molar masses. Everybody in here have one? Guys, you're going to need one. So get it out, get it out, get it out. If you don't have one, come grab one. Got a stack of them right here, guys. I mean, I don't know how you do this fast, grab one. So go grab your periodic table. Come grab one if you don't have one. You're going to need it. Periodic table, grab it. Forget yours. All right, so we need to find the molar masses of our two substances working with. We're working with propane and oxygen for this problem. So let's start with MM. We usually use MM for molar mass. Molar mass. C3H8. So we're looking for a molar mass of propane. Is equal to, well, we're going to start with carbon. We look at the periodic table, we find carbon, and there we go, 12.011. Grams per mole. It's the mass of 1 mole of carbon. Guys, this is not a good unit to get chintzy on your units. Not a good time to start doing that. Take your time. These problems are not built for you to solve in 30 seconds. Slow down, show your units. It is more important to get your units right than that you get the right answer. So slow down, show me your units. Don't get chintzy on those. It takes an extra 5 seconds. You're more than capable. Here's the thing. We don't just have 1 mole of carbon, though. We have 3 carbons. Multiply that by 3. Plus, we also have hydrogen. Off the periodic table, we find hydrogen, 1.00794. If you can't read that, sorry, but you have your own. Go get it out. Make sure it's putting unit on that, grams per mole. And this one I want to multiply by 8. I've got 8 hydrogen. Put 8 outside then. I'll go ahead and crunch these numbers in and let the calculator do all the heavy lifting. I personally just type it in as I see it. I use those parentheses. Believe it or not, your calculator is really smart and can figure that out. I do not hit a time symbol. You guys are allowed to hit the multiplication button. That's fine. Nothing wrong with it. But I just like to use parentheses and hit it in as I see it. So 3 parentheses, 12.011, close parentheses, plus 8 parentheses, 1.00794, close parentheses. Hit the compute button. There we go. 44. 0.09. I'm going to stop for a minute and think about significant digits. It's been a while since we worked at significant digits. This is an addition step. So it doesn't matter how many significant digits. It matters how far behind the decimal. This one goes 3 spots behind the decimal. This one goes 1, 2, 3, 4, 5 spots behind the decimal. We're going to be limited to just 3 spots behind the decimal because of this one here. So really, my next number, that 6, is my last significant digit. But this is not my final answer. So I want to do what's called carry extra digits. That means I don't just want to round off that 5, 2. If I round it off, I might get what's called round off error. So if I round too early, I might get round off there. So I've got these extra 2 digits, the 5 and the 2, but I need to show that they're not significant. The way that I do that is I underline them. They're there. I'm not rounding them off just yet, but they are not significant, so they are underlined. So there's my grams per mole for propane. That's my molar mass of propane. But we got to do the same thing for oxygen. Hey, diatomic, super, super important. If you guys have not memorized your diatomics yet, please at least write them down somewhere where you're going to see them all the time. You need to know your diatomics. They're important last chapter. They're even more important this chapter. Just take a look. When we say oxygen, we can't just say one oxygen, 15.994. We can't just say one because there's two of them there. So when we're talking about oxygen, we actually have to multiply that number by 2. So knowing your diatomics is super, super important again. Please make sure if you're not going to memorize them, you at least write them down somewhere that you're going to have that information for you all the time. So mass of oxygen, 31.9988 grams per mole. Ahmed, hey, pick your head up. It'll help. Don't be so tired if you got the head down. That helps. Did you have a big lunch? Yeah. All right, everybody's ready for the next page? All right, now it seems like we did quite a bit of work just now, but ultimately all we were doing is getting ready to solve this problem. Yeah, these are pretty big problems, stoichiometry. They may take a good portion of your page just to solve one problem. That's fine. That's okay. You only have a few of them a night for homework. Slow down. Do them correctly. Show all your work. In good shape. All right, number one, this will seem nitpicky. It absolutely does. It absolutely is. But there's a reason for it. Number one, start with a question mark next to the unit you're looking for. I know that seems nitpicky. I know you aren't going to want to do it. It won't seem natural, but do that. Start your problem off with question mark unit you're looking for. It's really helpful. And not just this chapter, but guys, in future chapters, we aren't going away from this stuff. We're going to continue to use it and use it and use it. And it's going to get more complex, more complicated. So always decide what you're looking for and start with question mark that unit. So for instance, question mark, well, what are we looking for? We're going to go back a page here. We're looking for the mass of oxygen. So question mark, what do we use for mass? Grams, O2. So we're looking for the mass of oxygen. Now I'm going to skip a couple lines because it's going to take me a couple lines to solve this. I'm going to come down here, number 2. After what you're looking for an equal sign. So what are we looking for? Equals what they gave us. What did they give us? Again, let's turn back to the previous page. They gave us 0.650 grams of propane. Now we've got our problem set up. What mass of oxygen is needed to combust 0.650 grams of propane? Cool. Now we're ready to start putting our problem together. Hopefully this looks familiar to you guys. Picket fence action. It's all about the units. All about your units. Set up units to go. Mass of A. Oops, off the page here. Set up units to go mass of A. All right, that's what we have. In this case, our mass of A is propane. To moles of A. Once you have moles of A, we can go moles of B. In this case, we're trying to get to oxygen, so B will be oxygen. And finally, moles of B to grams of B. We want to line our units up to go in that order. How do we do it? Well, to go from grams to mole, we need a molar mass. Calculated on that previous page. Molar mass of A will get us from grams to moles. From moles of A to moles of B, we have a mole ratio. That's what our balanced chemical equation was for. Gives us the mole ratio. And then moles of B to grams of B, well, once again, we can use our molar mass, this time of whatever B is. All right, so let's set this problem up and do it. We know that we need mass of propane down here. How do we know that? Because it has to cancel out. I want grams of propane divided by grams of propane. That way it cancels out. If I do grams of propane times grams of propane on the top, I end up with grams of propane squared. It doesn't cancel out at all. I want that. So I need to get grams of propane on the bottom. Hey, that's the number we've calculated over here. At the bottom, there's our grams per mole. I need to get the grams on bottom. So 44.09652. Don't forget to underline that 52. That's grams per mole. And again, don't get chintzy on the units, guys. Way too often I see people just put moles and grams. I'm like, well, I put my unit. No, you need to put grams and moles of what? We're about to have moles to moles. You can't say moles to moles is equal. Let's say moles of what? So slow down, add in what those are. It'll make more sense to you. Yes, it'll take you a little bit more time, but it'll make more sense. You'll see the problem so much better if you're using units. Cool. So we are done with grams of propane. We've canceled that out. Now we have moles of propane. The next thing we need to do is go moles of A. A is propane in this case. To moles of B. For that, we need our balanced chemical equation. So it's either going to be 1 mole of propane to 5 moles of oxygen, or 5 moles of oxygen to 1 mole of propane. That's what our balanced chemical equation tells us. 5 to 1 or 1 to 5, either way. Which way do we want to write it? Well, we want to make sure that we get moles of propane on the bottom. So We'll use the one that has moles of propane on the bottom. 5 moles of oxygen to 1 mole of propane. Yusef, stay with us. Keep your head up. Hey, I ran out of room. We still have one more step. I ran out of room. It's common. Unless you write really small, it's going to happen. That's okay. We'll just come down here. First of all, though, we get rid of moles of propane. We've canceled that out. It'll divide out. Moles of propane divided by moles of propane is just 1. Doesn't affect anything. All right, so our last step here, we've got moles of oxygen. We need to go to mass of oxygen. One more time, got to flip back to the other page here. There's our grams to moles ratio. I need to make sure I get the right unit on the bottom. I need moles of oxygen to cancel out. So 1 mole of oxygen to 31.9988 grams of oxygen. Guess what? That cancels out. And we only have 1 unit left, grams of oxygen, and voila. Here's the beautiful part about starting a problem like this. Look at that. I now have the unit I was looking for. I know I'm done. I know I can stop because I took the time to set the problem up correctly. Haha. Now it's just a calculation thing. Hey, kiddos calculators, type this in with me. Type this in with me. You have no idea how common it is for people to set up a problem perfectly like that and give me the wrong answer. It's crazy. This should be the easy part. You've done all the hard work, and then you don't enter it in your calculator correctly, and you lose points because you're just not calculating it correctly, which is silly. So get out your calculators. Jack, calculator. You don't have a calculator. What? Okay, you need to start bringing one for this class. We're using them a lot in this class. All right, so type it in. Type it in as you normally would. Make sure you get the same answer as I get. That's kind of the key to this. When you go home and start doing your homework, if you get the wrong answer, you're not have no idea it's the wrong answer. Whereas if you do it right now, you can compare your answer to my answer and see that it's the wrong answer. Then you can call me over and I can maybe work with you and be like, here's what you did right. Here's what you did wrong. Here's where I can help you. So double check in your calculators, make sure you're doing it correctly. So I'm going to start off with that 0.650. Any number on the bottom, we divide. So 0.650 divided by 44.09652. So here, so we see it a little bit better. Now, if you want to, you always multiply the numbers on top. If you want to, you can multiply by that 1 right there. But identity property, it's not going to do anything, so we can just ignore it. We don't have to worry about that 1. I am going to multiply by 5, though. That 5 right there is on top. So multiply by 5. Again, if you want to, you can divide by the 1, but we don't have to. Identity property. Come down here then, multiply by 31.9988. Press the enter button. Double check. Did you guys get the same value as me? And if not, now it's time to let me know. See if we, do we do something wrong? What can I help you with? What are we not doing correctly? Are we getting this number here? All right, let's record that then. Significant digits. Significant digits. All right, we started with 3. This number here has 3 digits. Leading zeros don't count. That is a leading zero. It does not count. Trailing zeros do count when there's a decimal. We have a decimal. That's a trailing zero. It counts. So 3 digits. This one is 1, 2, 3, 4, 5 digits. Okay. These are infinite digits. There's an exact amount, 5 to 1. This one has 1, 2, 3, 4, 5, 6 digits. Okay. Well, we're going to be limited to 3 total digits. So multiplication step doesn't matter where the digits are. All that matters is how many there are. We have 3. Our answer should have 3. So 2, the 3, the 5 will be our last digit. Let's look after the 5. I got an 8. Gia's got an 8 also. So the 8 at the end there is going to have us round that 5 up to a 6. Put our unit on it. Grams of oxygen. Hey, get in the habit of doing this. Put a box around your answer or circle it, or I've had students in the past highlight it. Whatever it is, whatever the case may be, guys, you're going to have a lot of work on your paper. You're going to have a lot of numbers in your paper. You want whoever's grading to grade your right final answer. Highlight it for them. Circle it, square it, whatever it is. Make it stand out. Questions?
When you were putting it into the calculator, did you put the 5-2 in when you were dividing? Like the underlined numbers?
Oh, yes, absolutely. Um, so what Caitlin's asking are these last digits here. Yeah, the whole reason why I still have them is because I don't want round off there. Sometimes if I get rid of these, like if I were to just round that up to a 7 and say, boom, we're done, that's my significant digits, sometimes you get what's called round off there. I don't know if you would or wouldn't for this particular problem, but I do know back in the day when we used to test, I would have test questions specifically designed that if you rounded off too early, you'd get the wrong answer. That wouldn't be hugely wrong, but it'd be enough that whoever's grading it knows that they rounded too early. So yes, if we go up here, we take a look at my numbers. Here's the 44.96, and there you can see the 5.2. Yes, I did. That didn't do anything. Tried to add some light. That's a little bit better. Yes, I definitely added that 5.2. That's why I kept it. So yes. Kept the 5.2. That's Caitlin's that answer your question? Awesome. Good. Cool. All right, lots of work for a stoich problem. Yeah, these are pretty big problems. But here's the nice thing. A lot of times I have a follow-up question, and you've already got most of the work done. So there's kind of a silver lining to these types of problems. So let's do one more example here. So a lot of times they give you a follow-up question. We've already done all the, well, not all of, but most of the heavy lifting for this problem. So now we're being asked, all right, here's how much oxygen it's going to take to burn all that gas. Now we're being asked how much water will be produced. Well, we can figure that out. And like I said, we've actually got most of the work done. Question mark. What are we looking for? In this case, we're looking for water vapor. So what mass of water is equal to, and again, working with the same stuff we were, so we're just going to start this the same exact way, 0.650 mass of propane. Hey, first step is going to be the exact same as it was up here. We're going from mass of A to moles of A. So I just use the numbers from up here. I want to underline those extra digits. So there's my molar mass of propane. Again, I've done mass of A to moles of A. Now I got to go to moles B. I know it's going to start off looking the same. Moles of propane on bottom. Here's the difference. Here's where it gets a little bit different than what we have been doing. Instead of going to oxygen, up here we went to oxygen. Now I need to go to water. Well, turn back. Okay. Here's our balanced chemical equation. 1 mole of propane, so that number hasn't changed. 1 mole of propane is going to make 4 moles of water. Sorry, you're right. Yeah. You okay? Yeah. We start serving coffee with lunch. Keep you guys awake. Cool. Hey, now we've gone from moles A to moles B. We used our balanced chemical equation to do that. It's a little bit different than up here, but that's because our balanced chemical equation is 1 to 4, not 1 to 5 like it was up here. So use your balanced chemical equation. Last step, we need to go from moles of B to mass of B. Going to need 1 mole of water on the bottom because it's on top up here. And we're going to need to calculate a molar mass of water. I don't know off the top of my head what mass water is, but that's okay. We've got a periodic table. We can put it together. Molar mass of water, we're going to have hydrogen. And we're going to need to multiply it by 2. There are 2 of them. And then we're going to add that to the mass of oxygen, 15.9994. Break out my calculator. I'm going to let that do the heavy lifting. I don't need to do all that mental math. 2 parentheses 1.00794 close parentheses plus 15.9994 enter. Double check our significant digits. I go 1, 2, 3, 4, 5 places past the decimal. 1, 2, 3, 4 places past the decimal. So I'm limited to only 4 places past the decimal. 1, 2, 3, 4. I'm going to underline that 8. It's not significant. I'm not going to get rid of it. I don't want to round it off. But I'm going to underline it to show it's not significant. Cool. Hey, that's grams per mole. And that's what I'm looking for right here. How many grams per mole? Grams per mole. Let's go back, double check. Grams of propane cancels out, right? Grams of propane divided by grams of propane is 1. It's gone. Moles of C3H8, moles of C3H8. They're on opposite sides. It's a division thing. 1, it's gone. Moles of oxygen. Opposite sides, they divide, I'm sorry, not oxygen, water. Moles of water, they're on opposite sides, they divide out. The only thing we're left with is grams of water. And again, we set our problem up. We know what to look for. And there it is. We have it. We're good. We just need to calculate, crunch the numbers. Again, I advise you to do this with me. Double check. Make sure you're getting the right answer. It is always shocking how many times people can set the problem up perfectly, which is the hard part, and then mis-enter into the calculator. It's like, you lost the easiest point there is. You'll miscalc point. Let's double check for significant digits. 3. The leading zeros don't count, but trailing zeros do. That's 3. A lot more than 3. Infinite. And a lot more than 3. We're going to round to 3 digits. This time the 2 is not enough to round the 6 up. So 1.06 grams water will be produced. Highlight it, circle it, put a box around it. That's the answer you want whoever's grading to grade. But I'll tell you what, guys, way more points in your final answer is your work and those units. You have to have those units. First of all, you're gonna mess yourself up. You're gonna get confused if you don't have the proper units. Over the next couple of chapters, we're gonna start putting different things in here. We're gonna start putting liters in here. You can figure out a volume. We can put energy in there, kilojoules. We can put in protons. We're gonna put in all sorts of different things, not just moles to grams. So this chapter, concentrate on the basics, learn those moles to grams, but don't skimp on the units. Those units are everything. I don't know what stoichiometry means, but I imagine it's something very similar to units. It means units, units. This chapter is all about those units.